Dear students, today I will discuss a few more problems on current electricity. In the last class, we have completed up to 10 numerical problems. Today, next problem is about Kirchhoff's loop rules or Kirchhoff's junction rule also included in this. So, firstly, today's first problem, problem number 11. Two cells of EMF 6 volt and 4 volt having internal resistance 3 ohm and 2 ohm respectively connected in parallel so as to send a current through an external resistance of 8 ohm. Find the current through the cells and PD across 8 ohm resistor. So this is the problem actually. Find the current through cells is there. If it is only PD across 8 ohm resistor, in the previous class I have discussed, without that currents, if currents are not required, current through the cells not required, PD across 8 ohm resistor we can do in alternate method. Let me tell you briefly at the end of this problem. Now firstly let me put the diagram. Whenever we have to apply Kirchhoff's loop rule or Kirchhoff's junction rule, we have to put the circuit diagram. Okay, so now there are two cells connected parallel and another 8 ohm resistor also connected parallel. So one cell like this, another cell, okay, two cells. We can put the resistor in between the two cells here also or at the bottom also. Okay, like this also we can put. Like this we can put the circuit diagram. Now let us label the quantities given. So here EMF 6 volt and internal resistance of first cell is 3 volt, 3 ohm internal resistance. Second cell EMF is 4 volt and internal resistance is 2 ohm. Okay, so then another external resistance is 8 ohm. Now the question is find the current drawn from each cell. So let us take the first current here, that is current drawn from the first cell be I1 and current drawn from the second cell. Normally we take the current outward from positive electrode or positive terminal of the battery. So this is plus, actually this is minus. It is understood, not necessary to put like this. Okay, so the current here it is I2. And now you see the junction. Okay, here I write A, B, C, D just for the sake of loop, EF. Let me label. Even though the electrical connections are here like this, they are at the same potential, not necessarily take A and B separately, but let me take here just for the sake of loop. Okay. Now here current I1 from the first cell and current drawn from the second cell is I2. And now see at the junction B, there are two currents entering. Current I1 is entering like this. Okay, current I1 and current I2 is also entering the junction B. So the total current here, according to Kirchhoff's junction rule, the current entering the junction equal to current leaving the junction. You can take it as I3, but that I3 is I1 plus I2. Okay. I don't write I3 because we have to reduce the number of variables to solve the equations. If I write I3, then I have to find out I1, I2, I3. Three variables I have to solve. If I write this as I1 and I2, I1 plus I2, applying Kirchhoff's junction rule. Okay, so currents entering, sum of currents entering the junction B equal to current leaving the junction B. So only one current, that is sum of two currents, I1 plus I2. Okay, so now the current through 8 ohm resistor becomes I1 plus I2. Current through 8 ohm resistor is I1 plus I2 like this. So this is about the circuit diagram for the given problem. Now problem is converted into figure. Now we have to apply Kirchhoff's loop rule. Okay, firstly, when I apply Kirchhoff's loop rule, we can apply any way for any loop. Here we have in the problem, there are two unknowns, two variables, I1 and I2, two unknowns are there. So we need a minimum two equations to solve the values or to find the values I1 and I2. Okay, first we can apply the Kirchhoff's loop rule to the loop A, B, E, F, A. Okay, so question number 11, applying Kirchhoff's loop rule to the loop, okay, to the loop A, B, E, F, A, B, E, F, A AB part, the only current is there, but there is no potential difference between A and B because it is electrical connection by the good conductor. So the potential drop may be negligible. So that IR product is 0 because the resistance between A and B is almost negligible or almost 0. So that's why we don't take any value here. A to B, there is no potential difference, or potential difference between is negligible value. Now B to E I go, I traverse like this direction. Okay, so this way, anti-clockwise direction or clockwise direction also we can go. So now I take A to B, B to E, E to F and F to A. This way I traverse. So A to B there is no potential difference or IR product value 0 because resistance between A and B is 0, approximately 0 or negligible it is. B to E. So first internal resistance is there and EMF is there for this. So there are two components. One is EMF value, another internal resistance value for the cell. I am traversing from positive terminal of the battery to negative terminal of the battery. So that's why potential will decrease in terms of EMF. Potential will decrease. So the -4 I have to take. Because when I go to here, EMF of the cell we have to take negative. When you approach the positive terminal of the cell or battery while applying Kirchhoff's loop rule, then you have to take a negative for that EMF value. Then IR product, we are moving opposite to the current direction. Current is flowing this way. We are traversing from B to E. So I into R product, resistance 2 ohm internal resistance into current, that should be taken as plus. So plus, okay, plus 2 into I2, 2 into I2, okay. Next E to F again, even though current I1 is there here, I1, okay, in that part, in that branch, but the resistance is again negligible, so you can ignore. Then F to A. So EMF of the cell, negative terminal first we approach. So here to here when we move, potential here is more by 6 volt. Okay, in terms of EMF it is plus 6. Then I into R product, current I1 we are going in the direction of the current. So IR product we are taking negative. So minus 3 into I1. Minus 3 into I1. So that is equal to 0. Because we reach the same starting point, that is A. In the electrical network, we start from one point and keep on moving on various branches and reach the same starting point, that is a loop actually. Then changing potential traversing through this becomes 0 when we reach the same starting point. Okay, so therefore changing potential in the RHS is 0. Now we have to rewrite this equation to simplify the equation. So I write here 2I2 minus 3I1, okay, plus 6 minus 4 is plus 2 here, okay, plus 2 or equal to minus 2 I write. 6 minus 4 is 2, then taking RHS it is minus 2, or we can change the sign and write as a positive value for I1. So in that case it becomes 3I1, this becomes negative becomes positive and positive become negative, so it is 2I2, okay, then equal to 2, only minus 1 multiplied throughout the equation. So then equation is like this. So equation 1 we label. Now we apply the Kirchhoff's loop rule to the another loop, another loop, either it is A, B, C, D, E, F, A or B, C, D. Smaller loop I will take. So I go like this now, okay. So applying Kirchhoff's loop rule again, applying Kirchhoff's loop rule to the loop, or simply write KVL. To which loop? B, C, D, E, B. B, C, D, B, E. This loop. B, C, D, E, B. Okay. B, C, D, E, B. So what happens? BC. Again resistance is negligible, hence IR product is 0. Then C to D there is a resistance of 8 ohm, and in the direction of current we are traversing. So minus 8 into I1 plus I2. Minus 8 into I1 plus I2. Okay, so the current into resistance product. Current into resistance product. Then D to E, even though there is a current I1 plus I2, resistance is negligible by the conducting wires. Then E to B. So again you see positive negative terminal to positive terminal means EMF. We have to take a plus. Okay, if you are traversing in such a way that first negative terminal of the cell approach, so then we have to take EMF as positive, and then I into R, current I2 and resistance 2 ohm internal resistance, that should be taken as a minus, okay, in the direction of current. So minus 2I2, that is equal to minus 2I2, that is equal to 0. Okay, so because we reach the point B. Now what we have to do is, so we have to simplify this equation like previous and get the another equation to solve. Okay, now first let me expand or divide by 2 throughout the equation, dividing by minus 2, dividing by minus 2. Throughout the equation, what happens, you see, 4 remains, minus 2, minus 8 by minus 2 is 4, 4 multiplied to this, so 4I1 plus 4I2, okay, then next 4 by minus 2 is minus 2, then minus 2 by minus 2 is 1, so it is I2, so I2 equal to 0 by minus 2 is 0, okay, so then writing the simplest equation, 4I1 plus 4I2 plus I2, 5I2 it is, okay, equal to 2. This is the RHS. 4I1 plus 5I2 equal to 2. So this is the equation number 2. Now we have to solve the equations 1 and 2 to get the required answer. We have to solve the two equations to get the value of I1 and I2. Then we can find the PD across 8 ohm resistor. Okay, firstly to get the value of here, observe the equations carefully. Here we have 3I1, here 4I1, and here 2I2 is there, here 5I2 is there. So how to eliminate this? We have to make the coefficients same. Then we can subtract or add. So here we can see it is 2I2. I multiply equation 1 by 5 and equation 2 by 5. So when I do that, what happens here, it becomes 10I2, this multiply by 2 throughout. So then I can write this equation as 8I1 plus 10I2 equal to 4, equation number 3. Okay, equation 2 into 2. Then next equation 1 can be written, equation 1 implies. So what I do, equation 1 into 5 I do. Equation 1 into 5 gives you, so 15I1, then minus 10 now. So 5 multiplied to minus 2 is minus 10, I2, okay, RHS is 5 into 2, 10, okay, equation number 4. Now you see, observe here, 10I2 is there, minus 10I2 is there, means by adding these two, we can eliminate I2 value. So adding equation 3 and 4, adding equation 3 and equation 4, we get 8I1 plus 15I1 becomes 13I1, sorry, 23I1, then next minus 10I2 plus 10I2 cancelled, 4 plus 10 is 14, okay, so then I1 equal to 14 by 23, so that much ampere, value of current I1 is 14 by 23 ampere, and the current I2 is required. So the simplest equation to get the I2 value, okay, so observe the equation 1 and 2. Equation 1 is the simpler equation to get the current through I2, branch current I2. What you have to do, substitute I1 value in the equation, okay, equation here we substitute, that is put equation I1 equal to, put I1 equal to 14 by 23 in equation number 1. So you get, okay, 3 into 14 by 23, okay, 14 by 23 minus, we don't know 2I2, so I shift into RHS and bring the 2 to the LHS, so minus 2, and that is equal to 2I2. Okay, so now I want the value of I2, so divide 2 throughout the entire equation, we can divide by 2, so I2 equal to, okay, dividing here 2, 14 by 2 is 7, 7 3s are 21, so 21 by 23 minus 2 is there. So 2 divided by 2 is 1. So that means 23 common denominator. Numerator is 21 minus 23 is minus 2 ampere. So what it says negative. We get the current I2 as negative. That means current will not flow from positive electrode outward this way. Instead the current will flow actually into the positive electrode. Current flows into the positive electrode. Okay, like that it becomes. Okay, so then that's what the minus sign here indicates. Minus sign, if any current is calculated found to be negative, okay, whatever we get by solving the equations, okay, we get negative value means the assumed direction should be opposite. Assumed direction is this way, the current direction should be this way, in fact, actually. So that's the idea here. Now the PD across 8 ohm resistor is required. Potential difference across 8 ohm resistor is required. Okay, that is PD. Here potential difference across CD also same it is. So that is V equal to I into R, resistance into current. So resistance is 8 ohm and current is I1 plus I2. So 8 ohm into I1 plus I2. Okay, I1 plus I2. Now substituting here 8, then I1 plus I2 means, so observe, I1 we got 14 by 23 minus I2 is minus 2 by, actually minus it is negative already, minus 2 by 23. So now 14 minus 2 is 12, so 8 into 12, 96, so 96 by 23 volt. So this is the potential difference across this. Decimal value you can calculate using the calculator. It is not compulsory actually. If you leave the answer in a fraction or ratio, there is no problem. So the decimal value 96 by 23 becomes 4.17 volt. 4.17 volt is the, okay, so that is the answer what we get. That is the current to the this one. Okay, so the answer, potential difference and currents, two currents and potential difference we get here in this. So the answer, final answer is 4.17 volt and the net current is 12 by, net current also we may require. So I1 plus I2, 14 minus 2 is 12 by 23. Okay, so 12 by 23 is the total current, that is 0.52 ampere. So that's all about this problem. Okay, so the logic is here, apply the Kirchhoff's loop rule. Whenever you traverse in the direction of current, take I into R product as a negative. Whenever you go opposite to the direction of current, so that I into R product you have to take a positive. And if a positive terminal of the cell approaches first, then you have to take EMF symbol negative for that. EMF you have to take a minus. And if negative electrode first you approach, while traversing, if you find negative electrode of the cell or negative terminal of the cell, then EMF term you have to take positive. And here in connecting part on the negligible resistance we take, hence the IR product for that connecting wires and all that branches you have to take as 0. So that's all about this problem. And alternatively I said using, suppose the question is only find the PD across 8 ohm resistor, it will be very simple. First find the equivalent internal resistance, 3 ohm and 2 ohm in parallel, Rp is internal resistance equivalent value. How to get 1 by Rp, 1 by R equivalent is 1 by R1 plus 1 by R2, or Rp, equivalent value of Rp you find. Then equivalent EMF of the two cells, then instead of two cells we can take a single cell of equivalent EMF epsilon EQ and equivalent internal resistance Req. Then we have to use the main current you have to get from the together equivalent cell. Main current means it is equivalent cell we have to take now. After that we get the current, then we get the potential difference or terminal PD. Okay, after getting the current drawn from the equivalent cell, we can get the potential difference or terminal PD of the cell, that is simply I into R, current into resistance. So that way also we can solve, that way I have solved in the previous session, previous class. Now I have another problem here, that is Wheatstone's network. Okay, So this Wheatstone's network, observe carefully. The question is determining the current Ig through the galvanometer of 5 ohm resistance, in the following circuit given below. So here there is a galvanometer 5 ohm. This is the galvanometer branch BD, and AC is the battery arm. So okay. So now here 10 ohm resistance, 5 ohm resistance. Here 5 ohm resistance, 10 ohm resistance. I said how to check whether it is balanced or not. If it is balanced, then the current to galvanometer is 0. But observing 10 by 5 ratio is 2, and here 5 by 10 ratio is 1 by 2. So 2 and half cannot be equal. So hence this network Wheatstone's bridge is not balanced. So whenever the Wheatstone's bridge is not balanced, there must be some current flowing through the galvanometer, either this way current or this way current. So in the question as it is given, galvanometer to current to galvanometer branch Ig is required to find out. So we have to solve the equation. So we can go for again simplifying. Okay, we assume the current through the galvanometer is Ig, whether it is given or not. Okay, so here in the question it is stated as well as shown in the circuit. Okay, it is shown Ig here, or simply the question can be find the current through galvanometer. Okay, so understood it is this is the galvanometer in the middle in standard circuit. Okay, now we have to take the currents, various branches. So let us take this current AB in this branch as I1. Okay, current, and here current through this resistor is say 5 ohm resistor is I2. Okay, then again Kirchhoff's junction rule we can apply. See, current going this way and this way, I1 and I2. Current entering the junction should be sum of the two. So current leaving the junction is I1 plus I2. So therefore current entering the junction also it is I1 plus I2. So that's what the flow of charges, rate of flow of charges. So if it is I1 plus I2, then it can be divided into I1 and I2. Okay. So two branches. Now here Ig current to galvanometer already given. Now out of I1 coming to the junction. So remaining current out of I1 is coming this way, current flowing this way AB through the branch AB. So partially it goes this way Ig. Then the remaining current, so the current remaining in this branch or flowing to the branch BC is I1 minus Ig. This is the current through that branch through 5 ohm resistor BC. Then now here you see again I2 is the current in this way entering the junction. Ig is the current entering the junction from the branch galvanometer branch Ig. So now the current through branch BC, that is a 10 ohm resistor, is I2 plus Ig. I2 plus Ig is the total current flowing through 10 ohm resistor. Okay. So this is what the circuit, and we have assumed the various currents and this one. Okay, symbols of that we have assigned. Now we have to apply Kirchhoff's loop rule. We find two loops easily. Then one more loop we take outer because we find here three unknowns. Okay, first let me apply Kirchhoff's loop rule to the loop ABCDA. So applying Kirchhoff's loop rule. Okay, applying Kirchhoff's loop rule, or simply I write KVL. Applying Kirchhoff's voltage law or loop rule, one and the same. So applying to loop ABDA. Okay, so to ABDA. Applying to ABDA, what we get? So A to B, we are traversing in the direction of current I1. So I1 into 10, 10 into I1, negative it is. Okay, so minus 10 I1. Okay, then next branch BD. So 5 ohm resistance galvanometer and current Ig. So again minus 5 into Ig. Okay, then from D to A, I2 is the current flowing this way, A to D, but we are traversing D to A. So I into R product is positive. So it is plus 5I2, and we reach the point A, started A only, so therefore it is equal to 0. So this is the first equation. We have to simplify this equation because it is a common factor of 5 is there. Okay, so now we have to solve this equation to get the simplest equation. Okay, so now I divide throughout by -2, dividing by -2. Okay, so what happens is here 2I1, okay, plus sorry, minus 2 not possible, here 5 is there, so only minus 5 we can do, dividing by minus 5. Okay, so it is 2i1, then minus 5 means plus ig. Okay, but I write I2 first, so after I1 I write I2, so it is I2 plus 5i2 divided by minus 5 means minus I2, then minus 5 by minus 5 cancel, so plus ig equal to 0. Okay, this is equation number 1 I take. Then next, the second loop BCD, second loop I can take BCDB. Okay, applying Kirchhoff's loop rule, applying KVL to BCDB. Okay, what happens? BCDB, same way. Okay, BC part, resistance 5 ohm, current I1 minus I. So minus 5. Okay, minus 5 times I1 minus IG. I1 minus IG. Then C to D. Okay, B to C, then C to D. Opposite the current direction. So I2 plus IG, 10. So plus 10 times I2 plus IG. Okay, then D to B. Again, opposite to the current direction. D to B means. So it is 5 IG plus it is. Plus 5 IG. Equal to 0. Now again 5 is the common factor, dividing by 5. Again I1 is negative. So what I do, dividing by minus 5 I do. Dividing by minus 5 throughout the equation. So what happens, it minus 5 cancel. So we left out here I1 minus IG. Okay, then here minus 2 times. Okay, here when you divide 10 by minus 5, minus 2. Minus 2 I2, okay, minus 2 into IG, minus 2 into IG, then here plus 5 by minus 5 is minus, so minus IG, that is equal to 0. Okay, simplest equation we can write here, I1, okay, that is, okay, so what happens, I1, then IG and I2, minus 2 I2 we get here also, okay, then we have IG, minus 2 IG, then minus ig. So minus 4ig equal to 0. Now applying Kirchhoff's loop rule to the loop ADCA. Okay, so applying KVL to another loop ADCA. ADCA means from A to B, B to C, then through this branch, battery branch. Okay. Okay, now AD part, current I2 in the direction we are traversing, so minus 5 I2. Okay, so then D to C, current is I2 plus IG and resistance 10 ohm. So minus 10 times I2 plus IG. I2 plus IG. Then next C to A. C to A means through battery or through the cell we have to come. So in the direction of current, resistance 10 ohm is there and current is I1 plus I2. Here the current is I1 plus I2 drawn from the battery of cell. So it is minus 10 times I1 plus I2. Total current is I1 plus I2 because here two branches, current I1 and I2. So current drawn from the battery of cell should be I1 plus I2. Then EMF, here to here it will increase. So therefore it is plus 10 equal to 0. This is the equation. Now we have to simplify this equation. Okay, so simplification, again see minus 5 common factor is there. So dividing throughout by minus 5. Okay, dividing by minus 5. What happens here? I2, then plus 2 times I2. Again plus 2 times Ig, 2 times Ig, then again here plus 2 times I1, again plus 2 times I2, 2 times I2, dividing by minus 10 by minus 5, it is 2 I1 and 2 I2. Okay, so then again minus 10, plus 10 by minus 5 is minus 2, that is equal to 0. This is the equation. You have to rewrite to get in the form like 2I1 is there. Okay, so 2I1, next 2I2, I2 plus 2I2, 3I2 plus 2I2, so 5I2, 5i2, then ig, here 2ig is there, that's it, 2ig equal to minus 2 in the LHS, take into RHS, it is plus 2. So this is the equation number 3. Next, equation 3. Now we have 3 equations. Equation 1 is this. Okay, equation 1 is this. Another equation is this here. Okay, this is the second equation we got for second loop, B, C, D, B. And this is the one more equation number 3. Okay, like this. We have to solve these 3 equations, okay, to get the value of ig. Now we have 3 variables. I want to solve only ig value. So how to eliminate I1 and I2? You have to get 2 more equations in terms of I1 and I2, or eliminate I1 and I2. Any one we can eliminate. So here 2I1 and here 2I1 is there. Easy it is, and we subtract one equation from another equation. I1 cancels, 2I1 and 2I1 cancels. So 5I2 is there, here minus I2 is there. So I2 will remain. Okay, so now equation 3 minus equation 1. Equation 3 minus 1, because see 2I1 minus 2I1 cancels, 5I2 minus of minus I2. So it is 6I2. Okay, then next 2Ig minus Ig it is. So subtracting means all the terms you have to make negative and add, that's all. So 2Ig minus Ig is plus Ig. Okay, plus Ig equal to 2 minus 0 is 2. This equation number 4 I call. Okay, equation number 4. Now I have to get one more equation in terms of I2 and Ig. Only I2 and Ig I have to get. I have to finally solve for Ig. I2 and Ig I have to get another equation. That means again I have to eliminate I1. Okay, so I use 1 and 3. Now I have to make use of second equation only. So to get solve here, I have to multiply equation 2 by 2. Then again it becomes 2I1. Again I subtract with 1 or 3. Again I can get. So equation 2 multiplied by 2 throughout. Okay, so equation 2 multiplied by 2. Okay, equation 2 multiplied by 2. What happens? You see, 2 into I1 minus. Okay, so 2 into I2, again 2 is there. So 4I2. Then again 2 into this, so minus 8Ig equal to 0. So this is the equation number 5. Equation number 5. Now I cannot get directly, we cannot solve these 2 equations. I2 is there. So this I1 again I have to eliminate this equation, I1. So equation here we can use, or any equation we can use. So first equation is there, or equation number 3. Okay, now I use equation 3 and 5. Okay, equation 3 and 5. What I do is equation 3 minus equation 5. Equation 3 minus equation 5 gives you 2I1 minus 2I1 cancels, 5I2 minus of minus I2, so it is 9I2. Okay, 9I2. Then 2Ig minus of minus 8Ig. Subtraction means I said the sign will change. Equation 5, all signs will become opposite. Subtraction means. So then add it up. So 2I1 minus 2I1 cancel, 5 minus of minus 4 plus 4, so it is 9I2. Then 2Ig plus 8Ig, so 10Ig. Okay. Then next 2 minus 0 is 2. This is equation number 6. Okay. Now we get so here 6I2 is there, here 9I2 is there. We have to eliminate. Okay. So eliminate I2 again. I2 again means we have to divide this or multiply. You have to make the coefficients same. Okay. So equation you have to eliminate, or another way is this equation also we can use. Okay. Now to solve this, you can subtract also. Direct subtraction will not give you the answer, because I2 we have to eliminate. We have to eliminate I2 to get Ig now. So okay. So now I multiply equation 4 by 3. Okay, or 1.5. I multiply equation 4 by multiply by 1.5 I do, I get 9. So So multiply by 1.5. So 1.5 into 6 is 9i2. Okay. 1.5 into this is 1.5 ig. Okay. So then 1.5 into 2 is 3. Okay. Equation number 7. Now it is found I2 same coefficients are there. So subtract now. So what happens is subtraction. Straight away subtraction is 6 minus 7 I can do 6 minus 7 equation 6 minus equation 7. Okay, so equation 6 minus equation 7 gives 9 into 9 into cancel. 10 minus 1.5 is 8.5 I2. Okay, 8.5 I2 equal to 2 minus 3 is minus 1. Okay, so multiply 2 both the sides and take this 8.5 that side. Okay, so I2 equal to, or I write this side, this implies I2 equal to minus 1 by 8.5. Okay, so you can take the value by using the calculator, you can find the value, or multiply 2 by 2 and 2, so it becomes a 2 by 17 ampere. So this is the current to galvanometer branch. Current to the galvanometer branch is minus 2 by 17 ampere. Okay, that's it. So that is the answer what we need actually. So this problem can be solved in a easy method. Okay, after getting the equations 1, 2, 3 by using Cramer's rule. It is not there in the mathematics syllabus. Otherwise Cramer's rule, it will be very useful and very quickly you can get the answer. We need not struggle in simplifying the equations. So that's the answer, minus 2 by 17 ampere. Now, so this minus sign indicates, here minus sign indicates current I2, current current IG it is, current IG is minus 2 by 17 ampere. That means because 992 cancelled, only 8.5 Ig it is, by mistake I wrote. Okay. So now the current is negative here, which indicates that we assume the current direction, or in the question they give the direction is from B to D, but actual direction of current should be D to B. As we got negative in the calculation, so current direction should be like this. So it doesn't matter because the question is only find the current through the given galvanometer branch. That's it. So the only answer is required, minus 2 by 17 ampere. Finished. Okay, that's all about this problem. Now another problem, number 13. Next problem I'll solve. So the logic is very simple here. Use the Kirchhoff's loop rule. So all the unknowns. So here we have to eliminate I1 and I2 to get Ig. That's the criteria. So 2I1 to I1 we can cancel by subtraction straight away, 1 and 3. But solving again one more equation using second equation, and with the 1 or 3 we can simplify. Again eliminate I1. Okay, then we get the equation in terms of I2 and Ig. This is the mathematics part actually, but this question was asked in the supplementary examination. So we cannot deny, or it cannot say it will not come in the exam. Okay, so questions can appear anyway. Okay, and this kind of question is there in the textbook also. Okay, solved question is there, one problem and one exercise question is given using Wheatstone's bridge when it is not balanced. Okay, now next problem, 5 resistors are connected between A and B. A PD of 10 volt is applied across A and B. Find the current I and through the resistor 3 ohm. So look at the diagram, it is again 5 resistors form Wheatstone's bridge only. 2 ohm here, 4 ohm, 8 ohm in the galvanometer branch, then 3 ohm and 6 ohm here. Observe carefully, 2 by 4 is 1 by 2, 3 by 6 is also 1 by 2. Hence what happens? This network is balanced in Wheatstone's network. When it is balanced in Wheatstone's network, the current through this branch is 0. 8 ohm resistor branch current is 0. Okay, so that's what we have to do. So that means that 8 ohm branch is not necessary, or it is it can be removed because there is no current flow and it is not useful. Okay, we can remove the branch 8 ohm, then we can simplify the circuit. So now the given circuit we have to verify. So question number 13. Firstly, what we have to do is we have to verify the resistances. Say R1 is 2 ohm. Okay, R2 is 4 ohm. Okay, the ratio R1 by R2 as per standard resistance 2 by 4 equal to 1 by 2, and that resistance R3, okay, R3 is 3 ohm and R4 is 6 ohm. The ratio R3 by R4 is 3 by 6 is 1 by 2. Okay, so therefore we can say R1 by R2 is 1 is balanced V-stones network. Okay, network is balanced V-stones bridge. Balanced V-stones bridge. So in case of balanced V-stones bridge, we can simplify this by eliminating the galvanometer branch. In such a case, 8 ohm resistance is eliminated. Okay, eliminated, as there is no current, as no current flows through that branch, no current flows through it. So that's the reason. Okay, so 8 ohm resistor, there is no current. Whenever it is balanced V-stones network, galvanometer branch, there will not be any current. Fine. Okay, through it. That's it. Now what you have to do? You have to eliminate. So if you eliminate, the circuit becomes like this. Okay, only this resistor will be there, this resistance will be there. Okay, and okay, like this we can write. Now you see 2 ohm resistor, and this is 3 ohm resistor, and this is 4 ohm resistor and 6 ohm resistor. So like this we have the points A and B. Potential of 10 volt is applied between like this. Okay, so here. Now you have to understand this question. These two resistors are in series. So effective resistance of 2 and 3 in series. So effective resistance of 2 ohm and 3 ohm in series. In series is equal to RS. Okay, so I write to the formula RS. I have taken this one as R1 and this is R3. Okay, R1 and R3. So formula becomes R1 plus R3. So that is 2 plus 3, that is 5 ohm. Okay, now another series resistance 4 and 6 are there. Effective resistance of okay, what and what? 4 and 6 ohm. 4 ohm is actually R3. 4 ohm is this R2 and 6 ohm in series. In series, okay, what I get is RS dash is this one is R3. 4 ohm is R2. Okay, so R2 plus and this one 6 ohm is R4. Okay, R2 plus R4. So that formula is must in solving. So that is 10 ohm. Okay, now we have two resistors. Let me write shortly here like this. So this is okay, so 5 ohm and this is 10 ohm. Now we can see 5 and 10 are in parallel. So effective resistance of 5 and 10 in parallel. Okay, next one more step. Effective resistance of 5 ohm and 10 ohm in parallel. 5 ohm and 10 ohm in parallel. Okay, in parallel. So effective resistance you have to get. So RP we have to get. RP is in general expression RP, RS. Here RS and RS dash. R1 R2 parallel combination effective value is R1 into R2 by R1 plus R2. So here RS into RS dash by RS plus RS dash. Like that you can write the formula. Okay, substituting 5 into 10 divided by 5 plus 10. So that is 50 by 50 or 10 by 3 ohm. 10 by 3 ohm is the effective resistance. Then we can get the value of current. Because we got the effective value now, effective value we got, we can calculate the current. How to get the current I? Main current I we can get in this branch. Current I we have to find out this branch, or current flowing from A to B, this point. Okay, the point, this one is B. Now that current you see, this effective resistance, one more circuit if you want I can draw. Like this one resistance is there, now this is there. Okay, so this is the point A where 10 volt PD is there. Okay, 10 volt PD here, and here it is point B. Between A and B, 10 volt PD is applied. So this is 5 ohm and this is 10 ohm. The current I is required. So current I equal to potential difference divided by total resistance of these two. Total resistance of those two is 10 by 3 ohm. 10 by 3 ohm we got. So V by RP it is. So PD applied 10 volt divided by RP value 10 by 3. Okay, 10 by 3. So that value 10 can cancel. It is 3 ampere. Current through current from A to B flowing is totally 3 ampere. It is divided into two branches. Now you see the parts. So I'll take this branch current I1, this branch current I2. Okay, so this is I1 current and this is current I2. So in the question it is asked to find out current through 3 ohm resistor. So 3 ohm resistor means this resistor. Anyhow this 8 ohm is not there. So current through 2 ohm and 3 ohm will be the same. Current through 4 ohm and 6 ohm will be the same, as there is no current through 8 ohm resistor, as it is balanced resistance network. That means I have to find out the current I1. Okay, current I1 is required. So current through 3 ohm. Okay, so the current through 3 ohm is, the current through 3 ohm resistor is, okay, current through 3 ohm resistor is. So what we can do is I1 equal to PD. Potential difference between this point and this point is 10 volt only. So V divided by resistance through that branch 5 ohm. 5 ohm actually we got as RS. So RS. V by RS. Potential difference V divided by the resistance of that branch. It is named as RS. We got the first series value, that is RS 5 ohm. So then I1 is, V is 10 volt divided by RS value 5. So therefore it is 2 ampere. Current through the 2 ohm resistor or 3 ohm resistor, it will be same, and that will be 2 ampere. Obviously total current is 3 ampere this way, and here it goes 2 ampere current, so it will be 1 ampere current. So because the resistance 10 ohm means 10 volt PD, so current through this branch will be 1 ampere current. So that's all about this problem, question number 13. So I think you understood this. So first question is we have to check the given network whether it looks like Weiston's network. Okay, by saying now we have to see verify whether it is balanced or not. Balanced or not just by observation. 2 by 4 is 1 by 2, 3 by 6 is 1 by 2, hence it is balanced. Then we can proceed like this. Now I go to the next problem. Okay, finding the effective resistance between any 2 points. Okay, whenever a circuit is given or a part of a circuit is given, finding the effective resistance between the 2 points. So such problems I work out now. Okay, resistance between the 2 points A and B. Okay, so now here okay, suppose I have resistors of question number 14. Find effective resistance between or equivalent resistance or effective resistance or total resistance between A and B. Resistance between A and B in the following network. In the following network. Okay, I will take some 2 or 3 networks. Okay. Okay. First one, the network is like this. Simple circuits I will take. Then I will go to the complex circuit. So suppose 2 resistors are there like this. Okay. Then here 1 resistor, and now here 3 resistors. Like this it can be given. This is the point B here. This is the point E. So effective resistance between A and B. Okay. So this I will take a 6 ohm resistor, and this is a 3 ohm resistor. It may be given in the problem. So I will take this one as 1 ohm resistor. Okay, so then here 12 ohm resistor, then 4 ohm resistor. Okay, then it is 3 ohm resistor. Like this. So there is a circuit between A and B. I have to find out the effective resistance. Okay, so in such problems, whenever asked to find out effective resistance, here I can see 2 parallel resistors. Here also 3 resistors are in parallel. So what I have to do? I have to write effective resistance between or effective resistance of 6 ohm and 3 ohm in parallel combination. Okay, in parallel combination. So RP formula is R1 into R2 divided by R1 plus R2. This formula I make use. R1 plus R2. So it is 6 into 3 divided by 6 plus 3. Okay, so that is equal to 6 into 3 is 18 divided by 6 plus 3 is 9. So that is a 2 ohm resistor. So instead of this 6 and 3 we can use or it becomes 2 ohm resistor. And here 1 ohm resistor is there. And now effective resistance of these three resistors in parallel. Okay, so effective resistance of 12 ohm, 4 ohm and 3 ohm in parallel. Okay, in parallel there are three resistors. Okay, we can use the formula R1 R2 terms only. So in such case I take 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now the values of resistances, or I can take R3 better, R3, R4, R5. This is R3 now, this is R4 and this is R5. Okay, so then now it is 1 by R3 is 1 by 12 plus 1 by 4, 1 by 3. So now LCM for 12 for 3 is 12. Okay, numerator is 1 plus, here 4 is there, 12 is there, 12 by 4 is 3. Next 3 into 1 is 3. Now 12 by 3 is 4 into 1 is 4. Okay, so then it is 1 plus 3 plus 4 is 8 by 12. So this is the value of 1 by Rp. So Rp, therefore Rp dash I take. Okay, Rp dash. So Rp dash value, this effective value is reciprocal, that is 12 by 8. Okay, 12 by 8 is 1.5 ohm. This we got 1.5 ohm. Now the circuit we can take three resistors in a series, correct? So the three resistors in series, I will I'll draw the circuit once again. So this is equivalent to one resistor, another resistor, another resistor. Okay, so this is a 2 ohm and this is a 1 ohm and this is a 1.5 ohm. So last one step is there, that is effective resistance. This is between A and B, means A and B here. Effective resistance of 2 ohm, 1 ohm and 1.5 ohm in series. In series, say RS, I write RS. So RS formula I write R1 plus R2 plus R3, adding all three resistors, but just for formality I will write the formula. So RS is first resistor 2 ohm, then 1 ohm plus 1.5 ohm. So it is 2 plus 1, 3 plus 1.5. So it is 4.5 ohm. So this is the effective value of resistance between A and B. So that's all about this problem. Okay, this problem about finding effective resistance, first problem. I will take another circuit, small circuit, to find out the effective resistance between A and B. So I hope you understood this. Find the parallel value, effective value of parallel combination. Again here also same way, effective value or effective resistance of the parallel combination of three resistors. Then now 1, 2, 3, three resistors in series. So effective value we get 4.5 ohm. Okay, so then I go to the next one more circuit. Okay, another circuit B, another problem I will take. Okay, so the resistors are given in such a way that, okay, to form a letter A. Okay, like this. Okay, now this is A point, this is B point, and here it is, okay, like this. This is the circuit. Okay, now resistance are like 2 ohm. Here it is 4 ohm I will take. Okay, this is okay, this is 3 ohm and this is 9 ohm. Okay, this is some 5 ohm I will take. So like this. Now between points A and B we have to get the effective resistance in this question B test. Okay, so this kind of problems also can be asked, or it can be a part of the big 5 marks question. Here you have to observe, I have to find out between A and B means, now this 3 and 9 are in series. So first I have to simplify these two. Okay, so effective resistance of okay, so 3 ohm and 9 ohm in series. In series is Rs equal to R1 plus R2. Okay. Okay, so that is Rs equal to R1 is 3 plus 9. Okay, so that is 12 ohm. So that is the 12 ohm resistance. Then after that, that 12 will be parallel to 4. This circuit becomes like this. Okay, so here it is 4 ohm as it is, whereas this is 12 ohm. Okay, then here it will be like this. There is no change. We have not touched that. So now this we have to simplify, this 4 and 12. Okay, this 4 and 12 we have to simplify, and the other two will be same, 2 ohm and this is point A, this is 5 ohm and this is the point A, and this is B and the resistance is 5 ohm. After that this resistors, this is 2 ohm and this will be single resistor and this will be another resistor 5 ohm as it is. Now this parallel combination of 12 and 4. Okay, so that is the effective resistance of 12 ohm and 4 ohm in parallel. So what happens? 12 and in parallel means RP it is. So R1 R2 by R1 plus R2 formula, just for sake of formality. So that is 12. It is compulsory to write the formula whether it is series or parallel. General formula we write, may not be particularly R1 R2. Okay, R1 into R2. First resistor 12, another is 4. So 12 into 4 divided by 12 plus 4. That value can be simplified as 48 by 16, that is 3 ohm. Then I have here 3 ohm resistor, 2 ohm resistor, 5 ohm. So that is equal to a single resistor, finally RS. Then lastly, effective resistance of 2 ohm, 3 ohm, 5 ohm in series. So finally it is RS, that is R1 plus R2 plus R3, formula is must. So that is equal to 2 plus 3 plus 5, that is 10 ohm. So this is the final answer. That's about the effective resistance between the 2 points A and B as given in the question. Here A, this is B. Okay, so final answer is 10 ohm resistance between the points A and B. So that means entire effect. So instead of having so many resistors in the combination forming a complex network,